Hi everyone and welcome back. Now in this video we are going to see the merge algorithm, and this is part 2 of this video. In the part 1 we have solved one problem statement saying that say you have two sorted arrays and your task was to merge those two sorted arrays such that the resulting array that you get is also sorted, right? So this was the problem, and the concept that we have used in that problem we are going to use in this algorithm at some point of time, right? So let's start the video on the merge algorithm part 2. Okay, so you can see I have pointed out some important points for you for this algorithm. Okay, so let's go through it one by one. So first point says that it is based on the divide and conquer. Okay, so what does this mean, divide and conquer? You may heard about like divide and conquer algorithms, right? So the main concept behind the divide and conquer is that you have a problem, right? So in this case, in the Marshall algorithm, basically you are going to sort that array. Okay, so you will be having, say, an array of size n. Your task is to sort that array. So if you go through this algorithm, then you will be basically using the divide and conquer. So in the divide and conquer, you have an array of size n. You divide that problem into smaller sub problems. Okay, so say you have an array of size n, you divide that problem into an array of size n by 2 and n by 2. Okay, so let's say you have an array of size n. Okay, and then you divide that array into n by 2. Okay, n by 2 and n by 2. Okay, again you further divide that problem into n by 2 and n by 2. Okay, you keep on doing that. Okay, so as you can see, this is the recursion, right? This will be a recursive call. So okay, so in the dividing we will be using the recursive call. We'll discuss that what will be the base condition to stop the recursion in the later stages of the video. As of now, just understand that dividing means we are dividing the problem. Now your first problem was to sort this array, right? Now your next problem is to sort these two arrays, then sort these arrays. Okay, so once you divided the problem into the sub problems, now your task is to merge them, means conquer the results. Okay, now you merge them. Okay, so once you got these 4 blocks here, let's say you have 4 blocks, now you conquer them or merge them to get this result. Okay, and then you merge them. Okay, so these blocks will be in sorted manner. Your task will be to just to merge these two arrays so that you get the sorted array itself after merging also. Okay, so as of now, just understand that what we're doing is that we are dividing that problem into sub problems, and after that we are merging it. Okay, so that's why this is called the divide and conquer algorithm. I hope you have got some intuitive, right? Okay, fine. So the next point says is that almost similar that I have discussed now, that this algorithm will divide the bigger problem into smaller problems. This is what we have done here, right? And it divides input array into 2 halves. So this is my input array, these are the 2 halves, and again it call itself for again 2 halves. So this itself called for again 2 halves, right? So you go on doing that, and after that then finally merges the 2 sorted halves. Okay, so these are the 2 sorted halves, we finally merge them. These are the 2 sorted halves, we finally merge them. Again, these are the 2 sorted halves, we finally merge them. Okay, we are going to look all the base conditions for the recursion, that when it will stop in the video. Okay, so just have patience till now. These are basic stuffs which we will be needing at some point of the time when we will be starting the Marshall algorithm, exactly, right? Okay, so we use recursion in this algorithm. I have discussed that we are going to use the recursion so that we can divide the problem into sub problems. Okay, so to divide the array into the sub problems means to do this task. Okay, we are going to use the merge sort function. In this pseudocode, we'll see that what is the merge sort function, but as of now, just know that we are going to use this function. Okay, for what purpose? To divide this into the sub problems, right? Now the next is that to merge the 2 sorted arrays. That means for this part we are going to use the merge function. As the name suggests, the name of the function only suggests that our task is to merge both the sorted arrays. Okay, fine. So these are the basic points which we need to keep in mind before moving forward to learn the algorithm. So I think you have got the intuition of all the points, right? And you also came to know that if we are needing the logic or the concept that we have learned in the previous part, that you have two sorted arrays and you need to merge both of them. So here also you will be having two sorted arrays and you need to merge two sorted arrays into the single array such that the resulting array is also in sorted manner. Okay, you can watch the previous video in a detailed manner so that it will be easier to understand for you. Okay, fine. So let's move on to the next part. I hope you have done with this basic points for the merge sort algorithm, right? So now let's take an example that how does this actually works, okay? Because just discussing the points will not do our task, right? So let's say I have an unsorted array as an example like this, okay? So let's say I have an array of, let's say, 2, 1, 6, 5, 4 and then 9, okay? So we have this array, okay? Now what we have done, we have to first divide this problem into the sub problems, okay? So let's say the first problem is into two halves. So how many elements are there? 1, 2, 3, 4, 5, 6, right? So we'll take three elements, okay? So first we take 2, okay? Just let me write it bigger so that it will be easier for you to see it, right? Okay, fine. So yeah, so you do this, you got this 2, 1, 6. Further you divide this, you got 5, 4 and 9. Okay, so this will be the first, after the first call of the function merge sort, okay? After that you again divide this into the two halves. What are the two halves? We have 3 elements here, okay? So we'll consider the 2 elements in the first half and the 1 element in the second half, right? Again you divide this into the same 2 problems, okay? And it will be 9, okay? Now again, since so our base condition will be, that means where we need to stop dividing the subproblems. It's obvious, right? When the array size has become 1 or the sub array size that we got has become 1, then at that point we have to stop, okay? And if the array size is more than 1, then we need to divide further and further, okay? So we have done with this, we need to divide this, okay? So you divide this into the 2 parts here, okay? And it will be as usual, right? So you divide this into this, it will be 2 parts, right? Yeah, it should be 5 and it should be 4. It will be as it is, okay? Now we have done with the dividing part. So we have divided the sub problems such that we got the problem of size 1, okay? So if you see this, this is my problem of size 1, okay? Fine. So we have divided, okay? Till now we got this, the problem of size 1, okay? Now our task is to concur them. So concurring means you are going to assume while merging that whatever subarray you have, those will be in sorted manner, and you are going to merge the sorted array itself. So here if you say we are going to merge both this 2 and 1, so this subarray, there are 2 subarrays here. This is the size 1 of size 1 and this is another subarray of size 1. Now as the singleton array having size 1 is already sorted, that means these 2 subarrays are already sorted, hence we are going to merge both of these subarrays so that we get an array which is also in sorted manner, okay? So once you merge this, what are you going to get in the sorted fashion, 1 and 2, okay? Again you merge these, okay? So once you merge this, what you got? 4 and 5. These subarrays of size 1 are already sorted, so we merge both of them to get the sorted array only, okay? Now again you merge these, okay? So if you see, now we have the size what? Subarray of size 2 and subarray of size 1. Again we merge them, both are in sorted, okay? 1 and 2 is sorted, 6 is already sorted, right? So we'll merge both of them such that we get the sorted array itself. So it will be 1, 2 and 6, okay? Now you do the same stuff for this. So what you will get? 4, 5 and 9, right? Okay, now you have the 2 subarrays of sizes 3. Now your final task is to merge these 2 subarrays so that you get the resulting array, right? So if you see, we're going to merge this. We'll get 1, 2, 4, 5, 6 and 9. Okay, so this is how we get the sorted array. If you see from here, okay, so this is what this sorted array is. Okay, so this is the basic concept that how the algorithm works. Okay, so I hope you got some intuition. If not, then please try it by yourself. It's simple, that you first divide the problems into the sub problems so that you get the problems or the sub array into the size of 1. Okay, and we already know that the subarray of size 1 is already sorted, either it is subarray or array, right? If it's of size 1, then it's already sorted. Hence, now next task is to concur or merge them. So we have merged the two sorted arrays, 1, 2. Then we have merged these two sorted arrays. We got 1 to 6. Then we have done the same steps for this. Okay, we'll be again seeing the example in detail, so don't worry if you have not understood it. Okay, so let's move forward to see the pseudocode for this. Okay, see pseudocode for the merge sort function and the merge function. Okay, so we'll see first the pseudocode for the merge function, that how this divides the problem into the two sub problems. Okay, so the return type of the function will be void, and you have merge sort here, right? And inside that you are going to take the 3 parameters. One is array itself, second is L, and third is M. So sorry, it's R. Okay, so what is L and R? So L is the starting index of the array and R is the ending index. Okay, so inside that, the base condition, as this function is going to call itself recursively, so we need a base condition to exit the recursion. Okay, so the base condition is for every merge sort function, this condition should be satisfied, otherwise you will have to return. Okay, so if this condition is satisfied, so our task is that you have an array of size n this, you need to divide into the size of n by 2. So for that, what we need to do, we need to find the middle element, right? So middle element will be given as L plus R by 2. Once you got the middle element, to get this array, what are you going to do? You are going to call merge sort again, and inside the merge sort, you will be passing what array L and the middle element. So first part we have done. Now again divide into the second part. So how? By calling the merge sort function again, and now I am going to take m plus 1 to r. So you got the second part, and finally we also need to merge both of these arrays, right? So for that I am going to call the merge function. So arr, in this I am passing the starting index, middle index and the last index also. Okay, and if this condition is not satisfied, then you just need to return here. Okay, so this will be this, so this. Fine. So this is the simple code for the merge sort function. Okay, so this is being used to say divide the problem into the first half, which may be called as LRR array, and this may be called as RRR array. So LRR means left array and RRR means right array, right? So this is for left array, this is for right array, and this is for combining both these arrays. Okay, fine. So now we are going to see that what is the pseudocode for the merge function. Okay, so before that we are going to just revise the concept that we have learned in the previous video, that how to merge the two sorted arrays, right? So say you have two sorts, 1, 3 and 4, and the second example is 2 and 6. Fine, this is our example, right? Okay, so again same, so do note that this is 3. Again you take I here, again you take J here, you compare both of these, which one is smaller? So bhai dekho, smaller one hai, I have put 1 here. Okay, again I increment I2 here, again I compare 3 and 2. Now in this case, which is smaller? 2, right? So 2 is corresponding to J value, so hence I will increment the J here. Okay, and put 2 here. Again I compare 3 and 6, which one is smaller? 3 is smallest, right? I put 3, I increment I2 here. Right? Again I compare 4 and 6, which one is smaller? 4 itself. Again I take put 4 here and increment I. Now again the value of I has become equal to the size of the left array. That means whatever the elements that has been remained here, we need to put into the array as it is. So here we have this remaining element is 6 itself. Okay, so I will put 6 here. Okay, so this is how you got the sorted array, by merging two sorted arrays. Okay, so I hope you have understood it. Now let's quickly move on to seeing the pseudocode for this merge function. Okay. Okay, fine. So let's see the merge function pseudocode quickly, and then we'll finish this off. Fine. So seeing the merge function. Okay, so the return type of the function will be again void, and this is the merge. And inside that, I have told you that I am taking the starting index, middle element, and the last index. Okay, and inside that, what I am going to do is that I am going to first define the n1 and n2. So what are n1 and n2? N1 and n2 are the sizes of these two arrays. Okay, which we need to merge and get this. So this array will be called as say LRR, and this will be called as RRR, and size will be n1 and size will be n2. Right? So n1 will be how much? N1 will be m minus l plus 1. N2 will be how much? N2 will be r minus m. Then I am going to define the two arrays of int. So first will be LRR of n1 and second will be RR of n2. Right? After that, I am going to copy the elements from L to M into the LRR. Right? So for that, I am going to use the for loop. I is equals to 0, I is less than n1, considering the 0 based indexing, and I plus plus. And you do just, and also you define one more variable k. Okay, so the value of k will be equal to L because the starting index is L. Okay, and we need to copy the elements from ARR starting from L, okay, to M. Okay, so L plus plus, I plus plus. Okay, so this is for copying the elements from ARR into LRR. Now let's write the code for copying the elements from ARR to RRR from M plus 1 to R. That means let's say J is equals to 0, J is less than N2, 0 based indexing, J plus plus. Again you do RRR of J is equals to ARR of K. You do K plus plus and you do J plus plus. Okay. So till now what I have done, I got the actual arrays LRR and RRR. Now what we need to do is that we need to merge this array. Okay, so we are going to write the code that we have seen in the previous video, that how to merge two sorted arrays. Okay, so for that, let's see. I am going to take first I am going to make the value of I as 0, J is 0 and K again to L. Okay, and then after that I will be using while loop here. The condition should be, as we have discussed already, that I should be less than N2 and J should be less than N2. And inside this while loop, what we need to do, we just need to compare both these arrays, both the elements at the ith position in LRR and at the jth position in RRR. So if you find LRR, then in that case you just assign the value of RRR of K is equals to LRR of I, it's I, and you do I plus plus, you do K plus plus. Else what you are going to do, that means the RRR of J is smaller than LRR of I. That means in that case you do ARR of K is equals to RRR of J, and you just increment the value of J and K here. Okay, so when you come out of the while loop, then either I will be equal to the size of the array or either J will be equal to the size of the array. So if J is equal to the size of the array, then in that case what we need to do is that we just need to put the elements that has been remained in the LRR. Okay, so say that this is your LRR and this is RRR. If J value has become equal to N2, then whatever the elements here are remaining, you just put it as it is. Okay, so for that I am going to use while loop and the condition will be same, right, again. Okay, and you do RRR of K is equals to LRR of I. Okay, and you increment both the values. Or next condition may be that I is equals to N1. So if I becomes equal to N1, then you, whatever the remaining values are there inside the RRR, you just keep it as it is. Again I am going to use the while loop. So J is less than N2 and ARR of K is equals to RRR of J you just increment the value of j and value of k, and you just return. Okay, and you stop here. So this is the pseudocode for the merge function. Okay, so I hope you have understood all the steps that I have taught till now. Okay, so in the next video we are going to see the analysis of this algorithm. Okay, so if you have not understood it, so don't worry, you may just go through this video once again, or you just take this code and trace by your own that what is happening actually. Okay, so that's it for this video. I hope you have understood it. So please like and subscribe the channel. So thank you and Jai Hind.